Welcome to Cope and Stick Panel Doors, a video that takes a look at cope and stick joinery using those two along with a raised panel to make a nice looking door for the cabinets you plan to have in your home or on your cabinetry. As we look at the parts, there are several different parts. I'm going to name them and then speak to their various joinery. First, the rail, which is the horizontal member of the door, and it'll have two cuts on it, and I'll explain those cuts in a minute. The stile, which will be the vertical piece, which will join to that joint like so and be snugged up, and then the panel, which will be the center or fill part of the door. Now, these three parts have different cuts on them, and I want to name the cuts and give you a little of the terminology to get you started. We'll spend more time as we get into the video, but I want to give you a brief review right now. Let's first take a look at the rail. The rail has two cuts on it. First, if we look at the end grain cut, you'll see that there is a cope cut that forms a tongue on the very end. On the edge, we have another cut that's formed. This is the stick cut. When the two cuts come together, they form a perfect miter there. The stile also has the stick cut on it, so that when we put them together, we form a nice tongue and groove joint. Now, if there is expansion and contraction in these pieces, there's still always a nice looking miter here, a nice tight fitting joint that holds the two together. The panel will slip into this door and float. That is, it's free to expand and contract somewhat so that it moves independently. And as we assemble the doors later in the video, you'll get a flavor for that as well. Now, the panel itself could be a single piece of wood, or it may be several pieces glued up. In this case, it looks like there's one single piece, here another single piece. Others that you'll see later will be glued up. This has been planed to 5/8 thickness, and when we put it together with the other parts, the top of the door, that is, all three of these will be in the same plane. If we were to put this 3/4 inch panel in, it would stick up unless we made some type of cut on the back to recess it. So if you do use 3/4 inch stock, and you may have to make a plan for another cut on the back. Now, let's take a look at the cutters we'll be using in this video. First, we've got a pair of cope and stick cutters, and one will cut the cope, one will cut the stick. As we pull these out of here, we can get an idea of what's happening. This is the stick cutter, and it will actually make the cut that forms the inside edge. This is a cut that we can make either first or second, and we'll talk about that later in the video. The cope cutter actually makes this end cut like so. Now, it'll form a tongue on the end, and when that's complete, the two parts, the two cuts are made, we're ready to assemble. The cutter that you see in the middle here is what we call a reversible cutter. It does the same job as the cope and stick cutter, except we reverse the cutters on the spindle to make both cuts. Well, those take a little more setup time, but they're less expensive. The dedicated cutters allow you to do the two cuts without changing any setups. So there are some benefits there. I've made up this chart to show you what happens, to give you an orientation here. The stick cutter does the rail and stile edges. That is, the inside edges of all of the parts will be cut with that. The cope is only cut on the rail end, two ends on each piece, so they'll both be cut. So once you've cut the rails on both, or once you've cut the inside edges on the parts, you may want to set the rails aside so you don't confuse them and make the wrong cut. Then we'll go to the panel raising cutter, and we've chosen a horizontal panel raising cutter here. We've used vertical in other videos, but the reason we've chosen the horizontal is we've gone to variable speed routers, which allow us to turn at a smaller or lower RPM, thus reducing the tip speed per minute of the cutter. All of these are important and part of an overall theme that I like to have in my videos, and that is safety. A few reminders as you go through. You'll always notice that we have barrier guards on our tables. We're working safe and smart. We always have our bits at least an inch into the collet. We're using hearing protection wherever necessary. And we're taking no chances as we go. We're testing our setups and working right. And I would urge you to do the same thing at home. Model the behaviors. One last thing, what to look for in the video. Look for all of the various types of jigs and fixtures and setups that we've used. We've used different types of router tables for different setups. We hope that you can learn from the many ways that we've done this and thus boost the number of ways that you can do the work at home depending on what equipment you have. So study these, watch the video a couple times, and you'll be better off because you'll have a mastery and a real feeling of confidence when you get in the shop. Now, I'm going to clear the bench, step out, and put up some new things so you can learn tolerances and some of the other things related to joinery to plan your doors to get them to accurate and exact size. So I'll be right back. I put out a couple doors here to help you understand the relationship of the parts. As we look at these, there is a terminology. These doors would sit vertically like so or be oriented like so if they were on your cabinet. The pieces that are parallel to the ground are the rails, just like the railroad, and that's the way I remember them. The vertical pieces are the stiles, S-T-I-L-E-S. And when we look at the cuts on them, there are 2 cuts on the rails, 1 cut on the stiles. The stiles have an edge cut, which is sometimes referred to as a rail edge cut or stile edge cut, and it is sometimes referred to as a stick cut. The rails have a rail edge and a rail end. Again, this is the stick cut, but the rail end cut is referred to as a cope cut. And if you've ever coped something to fit a mating part, it gives you an idea why it's called that. It's coped to fit around that part, so when they're put together, you get a miter-like look there and a perfect fit of the two going together. Any changes in the dimensions of the pieces with time will still give you that mitered look and a quality fit. Now, one other consideration you may notice as I put this stile next to the adjacent one, this one is wider. Is there a width that's expected? Yes and no. Typically 2 inches is a minimum. This is a 2 inch, this is a 2 1/4. I think you'll agree this one looks a little wider. It has a little more of a wood feel. However, on a small cabinet, that may be too much for the door. This may be more appropriate. 2 inches is the absolute minimum. 3 inches is typically the largest. Where might you use a 3? Well, let's suppose we cut a decorative edge on this side. What would be remaining as the flat of the door might be now less than 2 and would look ideal then with the shadows on both sides. You've got to keep that in mind when you plan and design the door for the dimensions. There are some other things that come into play here. And they are, first of all, how deep is this tongue go into the mating part? How thick will the piece be? And, of course, what's the relationship between the rail size to the door? Well, let's take a look at those. Typically, our stock will be 3/4, give or take, in thickness. Now, generally, give or take would be, say, a 1/16 to a 32nd, no more than that because they would be then too thin to support the panel. The depth of the tongue is usually somewhere between 3/8 and a half. On this particular one, it's 7/16. The width of the stiles will impact on the length of the rails just as the tongue depth will do that as well. Let's take a look at this relationship. I brought a flip chart into the scene here to give you an idea how this works. dW minus 2S plus 2G equals RL. RL is the rail length and what we want to have. dW is the door width, the intended door width that we've selected depending on whether we have a lip door, a flush, or an overlay. Minus 2S, and that would be the stile width. In other words, take the width of the stile. If it were 2, then it would be 2S or 4. So if the door were 11 and minus 2S, we're now down to 7 plus 2G, and if the G was a 1/2 inch, we would then add 1 inch, or the rail length would be 8 inches. So you can copy this down and refer to it in the video as you plan your doors, but this will allow you to get an accurate size every time. All you have to do is make a cope and stick cut on one piece and use that as the model for your setups. I want to direct your attention to one other thing that's very important. The depth of the cut, as you look at it, we have a nice rabbet here and we have some depth that makes the frame look richer. There would be a point of diminishing return. In other words, if the cutter were raised up, there would be less of this shadow line here. However, this back piece would be thicker. Generally, when we make a door up, this back rabbet or this portion on the back should be 1/8 of an inch more or less. Now, the more or less depends on your panel thickness, and we'll discuss that in greater detail as we get into that aspect of it. But for now, a good place to start would be to set that at 1/8 inch. Once we've selected our stock, and I've got some 2 1/4 inch stock that I'm going to cope the ends, that's the first cut I want to make. Notice that I've got this piece all sanded very well on the face. However, if you're to look at the back, you can still see a few mill marks. It would be important to know which way the piece goes into the router table, good face up or good face down, so that we'll be oriented correctly and we won't cut the part incorrectly, or worse yet, cut one end with a good face up, the other end with a good face down, and have a totally wasted part. So let's take a look at some of those things. I'm going to grab one of these parts to help you see how that works, and I'm going to step over to the router table now. I've got the router table set up now to cut the end grain. This has both the end and edge grain cut on it, but it'll serve as an example so we can see what would happen. I've got a setup now, an attachment to the miter gauge that's screwed on with a backing board to control tear out. When I make the cuts in the piece, I can slip this under here and clamp it like so. I can bring it through to make the cut. Now, the backing board obviously controls the tear out. A couple other important things. First of all, we have this clamping mechanism because as you shape end grain, it has a tendency to want to creep laterally. So by squeezing down on it, we can control that creep. Moreover, we've reduced the chance of creep by bringing our fences very close to the cutter. Those are also in line with a ball bearing in the center of the cutter. So what happens is, as I make this cut and I get about here, the distance is really about half of that, since the ball bearing picks it up and controls the depth. Once I leave here and I'm on this side, I'm still in contact with the ball bearing. So I've got excellent control over my piece, and that's a real important dimension to the cutting. Now, I also mentioned that the good face is down, and that's part of why we have this plywood piece here. After I've prepared my stock so nicely on both faces, or at least on the face that I'm going to have showing, by putting it on this board and clamping it, it doesn't drag on the table. Imagine having to make 2 cuts on here for each pass. That's going to cause more types of marks and require more sanding after the fact. So I like to get my stock to size, sand it up, and then I'm working with stock that's very true to begin with. Oops. Bring my part over, adjust for the cut, lock that down, check my clamp, yep, I've got plenty, and bring this down into place. Even with what I've done, we still have a little bit of fuzz there. That's not going to be a problem because when we shape that edge, that will go away. But for now, we're going to take care of all of the end grain on all of the parts, making the cope cut. Once that's done, we can take a look at the edge cut. I'll set up the bench for that, and we'll talk about that next step shortly. We left off with the cope cut being made, and now we've got to make the mating stick cut on the edge of the rails and also on the stiles. So some of our stock will just be the plain stock, and it will have a cut on it so that the 2 parts will match up. Again, we want to make sure our good faces are down because that's how these are run. In certain cases, I've actually marked on here GFD, good face down, or something like that to get my mind right, and that might be one thing that you'll want to do, or put a little X on your pieces and you have to see the X, or the X is hidden. Whatever it takes, that's a strategy that you should factor into what you're doing. Let's talk a little bit about some of the setup here. Here's a piece that's already been cut with the stick cut on it, and I'm just going to walk you through that real quickly, how I've got this set up. First, I'm going to move this out of the way so that you can see the cutter a little better, and I want to point out a couple of things about it. First, we still have that ball bearing that's going to roll on both. It's in the same plane as the fences and will roll on there. So it will control the stock and make the gap very small. Notice the fences are very close to the cutter to reduce tear out and also help keep us in control of the cut. Now, the piece, as we start it, will feed through like so. It will be picked up by a feather board here, and as I guide it through, it'll be cut, but it will also be under control for the complete cut. Note the bearing is still rolling, and the reason it's rolling is we've got a nice tight fit there. As we guide that through, I'll be using a push stick, not my finger, and the guard will be down. This will allow me to reach over here, pull my push stick out, and take this away clear. Now, there's one other thing that's important about the alignment of this setup, and that is the actual positioning of the bit itself. How do we get it in the right plane? Well, what we've done in this case is we've brought our piece in and we've lined up that tongue with the groove cutter, because the tongue and groove have to be in the same plane on the same thickness door for everything to be oriented correctly. Now, you could measure this, but measuring it might give you two chances to make a measuring error. You measure one piece, then you measure the cutter. That's two chances. By putting this up here and eyeballing it, you're doing what I call proving your arithmetic. You've probably heard me say that before, and it's a real good way of doing things. Boards know how big they are, and this is a way of finding where they belong. So once I've done that, I've got my pieces oriented. This would be one of the parts, and since it has one edge to be done, that's fine. Now, there will be some times that you actually do two edges. For example, in this case, there will be two stiles going up. This would be an intermediate stile with a rail meeting here. Since there would be a panel on both sides, I've got to make that stick cut on both edges, and it would be a matter of feeding the piece through, reversing it, and feeding it through again. I'll do a couple parts here to show you exactly how it's done. You'll get the feel of what's going on, and then you can practice on your stock at home. It's a good idea to do some of these test setups and make sure things are aligned. Once you get a couple pieces that you're satisfied with in a panel thickness, you can then use these as setup boards to position your cutter from that time on. But when you begin, this is the best way to go. Take that tongue, line it up with the groove cutter, and once you're satisfied that that's right, you're ready to go. I'm going to put the good face down on that so I don't make a mistake, and I've got the good face down on this mating piece. I'll put the guard in position here in a second, and we'll be ready to cut. That's a pretty nice fit. There's just about 32nd to a 64th sticking up there. Little sanding and that'll be right. I could tinker with it a little bit if I wanted to. In either case, I'm ready. Now, what you've seen here is the setups that we would use when we have a standard stick cut and a standard cope cut. In other words, we have two separate cuts. One thing we haven't addressed yet that we're going to move into next is the issue of handling this with a conversion cutter. That is a combination cutter where you reverse the cutters in there to make both the cope and stick. And we'll take a look at that here in a minute. I'm going to excuse myself, get some of the materials out, and then set up a new router table here for that. So I'll be right back to do that. We've set up the reversible cope and stick cutter, and it's a little bit different than what you've seen. Originally we had two separate cutters to do this. Now we have one cutter that does both by reversing the position of the cutters. Again though, we have a ball bearing, and that ball bearing lines up with our fence. This is a little bit more of a homemade style of cutting, and I thought I'd share this with you because I don't know what equipment you have at home. We've got a flat piece of 1/2 inch ply here with a 3/4 inch piece dadoed and glued in. We used a hole saw to cut this circle out, and then we coped this so it's very close to the periphery of the cutter. In other words, this is going to act as a chip breaker and help us stay in control with the cut. we've used some rain gutter type material and other plastic plumbing parts to make the dust collector up. It's important that you have dust collection because otherwise you don't get nearly the quality of cut, and there's much more bumping and jolting because you cut the wood more than once. Remember, the less you cut the wood, the longer this will stay sharp. We're set up right now to make the cope cut, and with a cope cut what you're going to find is in this setup we're going to work with a good face up. Now the ball bearing is parallel to the fence. This is also parallel to the fence, and this miter gauge type device clamps on, or actually shouldn't say clamps on, the piece clamps in. This slides along here, and I have a backing board with braces on it to help control the creeping. You can see that the backing board has handled the tear out that would occur as the cut is made. Now, this is my setup block, and I use this to set the cut up and check it, and I'm happy with it. Notice my setup block, well you probably can't see it from here, but I will tell you. It says good face up, meaning that when I put my stock in, the good face has to be up. You'll recall in some of the others it was good face down. All of these things require some kind of orientation and planning when you make the cut. If not, you're going to find that your pieces aren't going to fit exactly as you'd hope they would. So when I set this up, this piece will be butted to that fence. This will be butted to the edge of the piece. I'll put my clamp block on here and then push down. This will give me all the creeping strength I need. As long as this is against here, I'm set. Now that's a lot of cutter to be exposed for what I'm doing here, and one of the ways to eliminate any possible contact with the cutter is to put a barrier in place. I've made this barrier up. Notice these threaded pieces. These are what are called hanger bolts. They have wood threads on one end and metal machine threads on the other. These are available at about any hardware store. Once I've attached these, I can now use this from now on with the metal fasteners, and I'll just tap that down in place. I've got some metal washers here and wing nuts. This allows easy on and off accessibility so that I can set this up to be used with the cut, and I think you'll agree that I'd have to work overtime to get my hand in there, and that's the approach that I want to use. All right, this will be the setup for the cope. Remember, the good face is up, and you want to read the directions with any of these cutters because they vary. You need to make some practice cuts and get oriented before you go into your expensive wood that you've prepared well. But I'm confident with what I have, and I'm ready to go. So I'm going to make a couple cuts in these pieces, and then we'll talk about the second step. There's the cut. The copes are ready. Now we've got to make the stick cut. The stick cut is a little bit different, and what we're going to have to do is reverse the cuts. Let me direct your attention to this chart for a second. What we've done is we made the cope a rail end cut, and now what we're going to have to do is make the stick cut. When we make the stick cut, we take this cutter, flip it upside down, and we take the bearing out from between the cutters and put it atop the cutters. Once that's done, we're ready to make the mating cut. Now, with each set, there's a set of instructions that goes with this that gives you this information. Study that carefully so you're sure that you get what you need and make sure the setups are right. Okay, I'm going to break down here and proceed to make the mating cut. So we'll get back once this is set up and I'll explain the other setup to you. We're set up now to make the mating cut. And it was a matter of flipping the cuts as we discussed, or flipping the cutters as we discussed earlier. I wanted to point out one other thing. Notice this brass washer. It's actually a shim. And between the cutters we can insert these shims to control the tightness of fit. The beauty of this is that after these cutters have been sharpened a few times and they change size, we can shim the cutters so that the fit between the cope and the stick, or the two pieces, is still good and tight. Now, if you go to the double cutters, that is a cope and a stick cutter, make sure at least one of them has the capability of being shimmed so that you can make the fit work right. Once you've got that, you will have them for a lifetime. If you buy the ones that are single piece and dedicated, you may find that after they've been sharpened once or twice, the quality of the fit will be unsatisfactory for what you're doing. Again, I've set that ball bearing so it's in line with the fence on both sides. The cutter is not touching or hitting the fence in any way, so I know that that's set correctly. I use the same technique I always do to find the position of the cutter. I marked the tongue with the groove cutter, and once that was set, I knew I was in the right plane. Now, one of the things I've noticed now is that last time we did them good face up, but when I adjusted this, the only way that this is going to work is good face down. So I have put an X on my pieces so that I'll have them the right way. When I see the X, I know they're right. Now again, if I were to make this cut along here, I think you'd agree there's quite a bit of cutter exposed. So let's see if we can eliminate some of the cutter exposure. We'll put the pieces that have to go under there on and add a shim that's a light 1/8 inch. Then we'll put this barrier up like so. Once we get that positioned about where we want to be, we can snug that up. Those give us the clearance we need so that there's not going to be any binding in there. And now I think we're ready to make the cut. So how am I going to feed that through? I've got 2 push sticks and I'm going to use them like so. That way there's no way that my hands can get into the cutter. I'll set 2 of these aside and I'll cut them one at a time. So let's get the dust collector on. Once again, I'm within a 30-second. There's just a little bit of sanding to do. I have that nice quality look of a miter across there, and I'm satisfied with what I'm doing. Now, the difference between the cope and stick cutter that's reversible is you've got an extra setup, changing those, readjusting the height of the cutter. With the cope and stick, it's a matter of going from one to the other. You still, if you only have one router table, will have to remove and replace the router. The timing will be a little different. Once you have some setup pieces that help you decide where the positioning ought to be, you're all set. Now there's about one issue that we have not resolved about cope and stick cutting, and I'd like to spend a minute or two talking about that. I'm going to step over the bench where I have some material set up to discuss that. So let's go over there now. So far, we've made the rails and style cuts for a door. The entire frame is ready, and we've looked at a number of aspects. In all of the cuts so far, we always made the cope cut first, then the stick cut second. In other words, end grain, then edge grain. The question often comes up is, why is it this way? Well, tear out is a big problem, and that's one of the reasons we do the end grain first, because we're working with a square piece and we can compensate for tear out. However, the other side of the discussion goes like this. Suppose we were to shape all these edges and have long pieces, could we not then cut them to length and then cut the end grain secondly? This might be a good idea because we would allow us to cut long lineal lengths and then chop them to the lengths we need for rails and stiles. In this case, we have to cope with the end grain problem and possible tear out. And that becomes a big problem if we were to shape this side with a tear out coming through on our already shaped edge. We're going to have some problems. So that begs the question, how can we do this? Well, there are a couple of ways that we can handle that. One of the things that we can do is take the coping cutter and actually cope the end grain or the edge grain just like we did the end grain on this piece. We now have a strip that becomes a mate. In other words, if I were to take this edge now, it will slip in like so. This could be a perfect backing board. Well, let's take this discussion a step further. I'll rip the strip so that it is just a narrow piece, and then let me cut two short pieces, inch and a half long. Let me double stick tape those to my miter gauge at both ends. Notice this one's already been used because you can see that the cutter has gone by there and torn it up a little bit. So what this allows me to do is take that length that I've already cut, bring it around, slip it in here, position it, clamp it, and make the cut, coping with the tear out problem or compensating for the tear out problem. Now, the lengths that you may go with could be any length, 6 feet even, depending on what you have to support those pieces. If you have some take-off tables, you can go with longer pieces than this. This would allow you to cut your rails and stiles out of lineal lengths and reduce the amount of operations and the amount of handling. So having said all of that, you might say, well, what do I do on the other end? Obviously, that isn't going to work here. Well, we have another backing board that is a remove and replace. That is, all we have to do is take the other one off, slip this on, and we can make the cut on the mating end. Since we're set up this way, let's take a look at this setup and how it'll work on the router table. Everything has been preset. We've got a shield here to protect us, and if you look, you'll notice the height of my cutter is set identical to the positioning of these pieces, so that even though this is raised approximately a ½ inch, when I put this in place, there'll be no problem. So what I'll do is I'll butt that against the fence, and then I'll slowly squeeze it into place because it is a friction fit. As you pull that together, it is truly a cope and stick joint. And in fact, what I've done is I've actually relieved that. I've sanded away some of that material. So now it's ready. I've got it positioned. I can set my shield down in place. There's still a little bit of fiber that's broken loose, but it's a matter of rolling over, and all I have to do is take a sharp knife, cut that away. You can see I have a little feather there. This wood may be just a little thicker, or it may be slightly twisted. By cutting that out, I've got a piece that is perfect. There's no evidence of any tearing or chipping on the face, and that's exactly what we want. Now, what do we do next? Well, it's a matter of removing this backing piece and replacing it with another to make the mating cut. Once that's done, our part will be completed. So I'll remove this backing piece, and it slips out something like that. There we go. And then the mating one simply slips in like so, drops down once it's positioned. Snug up the screws. And I can flip the piece over like so, bring it into position, and clamp it. Now, if I had several of these, I wouldn't flip it back and forth. I'd do all of one end and then do the mating end. But to finish this off, let's do the other end now. Once again, we have just a little whisper of wood there. Cut that with our knife. A little bit of a piece here. Trim that out. No tear out again. And let's see how it would look. That's a nice fit. This piece is a little thicker than this one, but the fit is good. We've got our mitered look, and that's what we want. Now, thickness is another area that we've talked about. We want to make sure all the parts are the same thickness before we begin. There's a better fit. So, as we work with this, the cutter height has to be considered when we put this together. All of these are aspects that we want to factor in to the setups. Once it's set, we want to make all the cuts. All right, we've exhausted the frame itself. Let's take a look at the panel that fits in the frame and some of the aspects of making a raised panel, and we'll move into that now. I think you can see that we've got the frame, the cope and stick frame, put together around various panels, and that's where we're going to go next. There are two styles of panel raising cutters that we might use, either the vertical or the horizontal. Now, if you saw my 204, we used the vertical. In this video, we're going to use the horizontal cutter, which cuts a little bit differently. This will be the one we'll use in all of the operations. The vertically oriented one allows you to shave the panel in the vertical position. The beauty of this is it requires less energy to make the cut, but the downside is there's more deflection because it's so high it could wander at the tip, so there'd be more chattering. You may have to make 2 or 3 light cuts to get it done. The horizontal cutter is much more rigid and has more mass. It's located closer to the router and the table, so deflection isn't as big an issue. Also, since there has a ball bearing on the top, it can follow a template or a crown raised panel, something this router bit cannot do. Now, one other thing that's important here, though, is the tip speed. In miles per hour, the surface feet per minute is much higher with the horizontal cutter. So, what that means is we're going to have a variable speed router to handle this. That's why we chose this in 204. We had single speed routers and we wanted to run them that way as a single speed. Now, in this video, we're going to use variable speed routers and show you the techniques for making the cut. All of these panels were made with horizontal bits, and I'm going to share with you some of the techniques and some of the things that are important considerations as we go into this. One of the things you'll notice is, and they're subtle, so you may not notice it unless I point it out, but I'm going to take this ruler, I'm going to set it on the middle of the panel. Do you notice that there is quite a bit of space under each side of the panel? In other words, the panel is standing what we call proud, above the frame. This isn't really what we consider typical. As you look at this one, you may notice just a slight amount under there. This is pretty close to average or about right. That's good. Let's take a look at this one where everything lines up perfectly as we go across. This is what we would expect in a typical door. Now, there are some considerations here, and they are these. The thickness of the panel will determine where it is if the bottom of that groove is always in the same position. Remember, we said we wanted a 1/8 inch rabbet or a 1/8 inch groove, which means that there's 1/8 inch behind the panel. That means a piece of stock that was planed to 5/8 would fit perfectly if that were the positioning. That's fine, and there are some caveats to that. Let's go over here to the chart for a second and I'll share those with you. I've made this up to represent a rail or stile, and it's cut, it's the same scale as these are. Now, notice this 3/4 inch panel that's been raised. Nothing's been done to the back. So if we were to insert this in like so to make that cut, you'll notice that the panel would stand proud by about 1/4 inch, much like that first one I showed you. Now, if we wanted it to sit more likely as an even piece, we could put a 3/8 rabbet back here, 3/8 deep, 1/4 inch this way. And now when we bring this in, notice that we would get an even or flush front. That is, a 3/4 inch panel would be flush if we back cut it. Now, this square cut isn't really favored by a lot of people. Some would sooner have this slight curve here, and the reason they would is it looks much more decorative from the back side. In other words, it's like a mini raised panel when you open the door. So this might be a choice that you'd want to incorporate. There is yet one other. We could take a 1/2 inch panel and use a 1/2 inch panel raiser. Now what happens is the front lines up and the back is recessed. In other words, there's a rabbet around there where the back is. Is this a problem? Not really. Are there some advantages? Yes and no. Let's talk a little bit about what happens here. If we glue up panels to make a 3/4 inch frame, that is, we take 3/4 inch stock and glue it up to make a panel similar to this one, what you're going to discover is after you've sanded it and planed it to thickness, it's really no longer 3/4. If your pieces were off, say a 32nd on either side, that means this will be a 1/16 inch smaller, 11/16 instead of 3/4, which means then it doesn't fit any of these models exactly. It might be somewhere in between. Well, what that means is that if we had that problem, we might want to adjust this position so that the panel sits in the right place on the front. All this is a matter of orchestrating where the rabbet is relative to the thickness of the piece. Now, in this case, there's an 1/8 inch rabbet back here, and this is a 5/8 thickness. That is, I glued up 3/4, planed it to 5/8, and after I raised it, it gave me a beautiful panel that is flush with the front with the minimum amount of work, no back cutting. The back cutting that you saw in these two examples requires an extra cut, one more operation in the raising of those doors. Is that a big deal? Yes and no. How soon do you want to do them? Is this your weekend that you're building these on? Have you got a 2-week vacation to make all these doors? Then it may be a real important issue to you. So think about that a little bit and make your plans accordingly. Now, another way of doing it is not to worry about where the reveal is. You've got a 1/4 inch groove. You can put a 1/4 inch piece of plywood in here. These doors don't have the raised look or look nearly as proud, yet you don't have to worry about any deviation or error here. It's already solved for you because the back picks up the difference much like the 1/2 inch one would. It's no big deal. But we lose some of that difference. If we go to the 3/4 inch stock though, you can see how this one has been rabbeted or cut with that slight notch on the back. So we have 3/4 inch with a notch here to get the raise that we want. Now, one other thing that's very important here on all of these doors, you'll notice that this raise leaves a nice square edge around here, and that's very important. If we use a cutter that's designed for a different thickness, we may not get that edge around here. Our eye likes to see a straight line. We like to see something parallel with that edge. So by raising and leaving that, we do see a raise. This is called the field, and the field should be raised with a nice, sharp, crisp edge around there. Remember also that if you haven't sanded this beforehand, if you go back to sand it after you raise the panel, what's likely to happen to those crisp corners that you see here? Right. You're going to be back to sanding again or shaping again because you'll lose those, and now the line will look like a snake. It'll wander a little bit. So it's very important that all your prep work be done before you do the panel raising. So that's a little bit of an orientation to panel raising. I think now it's probably a good idea that we go over and take a look at a couple panel raising operations. I've got one set up over here, and I'm going to walk over there now and bring you over and give you an orientation there. So I'll meet you over there in just a second. This router table is set up for a 5/8 inch router panel. That is, the panel will be 5/8 thick when we're done. Now, let me show you a couple things that are important about this. With the cut set up just like so, panel is right. If I were to put this piece of stock down like so, push them together, it's a perfect fit. Since both good faces are down, that tells me that they are going to be in perfect alignment as we discussed earlier. Now, that's for 5/8 thickness. That's the way we're set up now. If I had a 3/4 inch panel, I would probably have the same setup, but I would have to cut some away from the back. We're going to take a look at 3/4 inch panels in a little later scene here, but let's just direct your attention to some of the features of this router table so you better understand and can plan how to do this in your shop. First, the type of cutter bit. We're using a relatively large panel raising bit. It has a ball bearing, and again the ball bearing is aligned with the fence. The fence is parallel to the miter slot. And the cutter is what's known as a chip limiting cutter. That is, this large form here, as the wood goes through, the cutter extends only slightly above that form, which reduces the amount of bite of the cutter, thus reducing the likelihood of kickback. Since the cutter is so big in diameter, you may recall we talked about feed speed and speed of the RPMs of the cutter. We have set this router, a variable speed router, to 10,000 RPMs. So the tip speed will be about the equivalent of what it would be in a 1-inch diameter router bit on a typical full speed router of 20,000. The whole idea here is we don't want a lot of bumping and jolting when we work with this. Again, we've got our dust collection set up. Very important, we don't want any bumping again. And if we cut that same piece 2 or 3 times, we get the jolting that sets up intimidation and a kickback possibility. The next thing we've got to do is take a look at some of the technique we can use. I've set a miter gauge in here, and what I can do is I can take a panel and butt it against here and use this as a feed device. With this clamping mechanism, I'm assured of control. But do I have to be against the fence? No, I could be out here about like so and guide this through, and I'd be taking half the cut. In other words, I'd be taking a light cut without changing the setup at all. Then after I've completed that, I could move it over the fence and make an additional cut. These are all specialty things that you need to be familiar with if you want to get the most out of your tooling. So having said that, I'm going to now set up for guarding. I don't want all of that bit exposed when I'm working, so let's take a look at what I'll do here. I'll set this in as close as I can get it, set my spacer on top of this, and then I'm going to position my barrier guard like so. Lift it up just a little bit so it clears and I can get that out of there. There we are. The barrier guard then makes it very difficult for me to get into that cutter. I would have to work at it. Yes, I could put my hands under there, but if there's wood under there, the likelihood of that happening is not very great. All right, I'm ready to go. Let's get a piece of stock here to be working with. And again, I want my best face down, and that face should be sanded relatively true to what it's to be. As I look at this, both sides are in very good condition, so I'll choose that to be my best face. And I'll start with the end grain. And I'm going to set it about ½ inch away from the fence. I'm going to tighten it down securely. Get my muffs. I did get a little bumping and jolting, and I think you noticed that I took a second cut because I wanted to make sure the panel was clean. We've always talked about that square area we want to see around the field, that raised area, and I think you'll agree that we have a nice straight line. As I look at the quality of the cut, there are no ridges. It's very smooth, but I think you can see the importance of taking a light cut. Now let's give it the real test. Let's put it down like so, bring this over, and check the fit. Once again, we're right on. Now, one other thing we can do to make this a little better is take the panel and pre-condition or pre-treat it for this. And what I've done here is I've actually taken a bandsaw and I've cut around here, removing most of the waste area. This now will allow me to go in and take one cut to do the same job. I'll demonstrate the end grain and we'll see if you can notice a difference. You can see that there's very little wood being removed because of all the sawing. I did get a few jolts, and if you look real carefully you can see a few lines on there. As you saw me make the other ones, I made a light cut feeding through by hand after it had been all the way around the panel. That was a cleanup cut to smooth those up. When you compare the two, you'll be able to see that this indeed is much smoother by taking that one last gentle pass across there. You may get some bumping, that's all you need to do, but by taking that last cut you'll cut your sanding down dramatically. So that's the approach for working with 5/8 stock if you have a 1/8 inch back to the panel. That is, when this piece back here is roughly 1/8 inch thick, you can plane your stock to 5/8 and be assured that the panel will be raised appropriately for what you're doing. If you're going with 3/4 inch stock, there's a few other things we need to do. Give me a couple minutes and come on back. I'm going to set this up. I'll be right back with that setup. Probably looks a little different here, and well, it should. We've changed the setup. We're going to be doing a raised panel in a piece of 3/4 inch thick stock. Remember, we still have that 1/8 inch rabbet there. So when we line this up, the groove has to be adjacent to that rabbet, which means we're going to have to back cut this. The only other way we could do it is to bring this back, and that's not possible. So what we'll do now is we'll make the first cut on it to get this, and then we'll readjust to cut it to the exact depth, and then we'll back cut the panel. Now, before we actually make the cut, I want to point something out to you. First, we will be using the miter gauge for the end grain, and in so doing, you'll recall that one of the things that we had to do was be sure that the miter slot was parallel to the fence. I want to show you an easy way of going about that. What I have here is a piece of stock that has a 3/4 inch straight edge on it. I'll slip that into the miter slot, bring this through like so, and push it in till it's wedged tight. Now you'll notice that I am parallel here and I'm tight here, which means the fence is indeed parallel to the miter slot. This is the quickest way of checking or setting this up that I know of. You can make something like this at home very easily, and you may wish to do so after seeing this video, especially if you've ever, like me, tried to improve your vocabulary setting this up. So that's a technique that you can employ right away to save you some time. Now I think we're ready to make the cut, and I'll look my stock over. This is the piece I want, and I'm going to put my best face down because that's the face that's going to be raised. I'll bring my miter gauge over, lock this like so, and I'll just set it away from the cutter for a second. Now I've made the first cut, but I still don't have the raise around here. When I make the second cut, I'm going to get a little nicer line around the field. Once I've raised that, I'll be all set. Now, one other thing you may have noticed is that I didn't check for tip speed of the router bit, but I have already set it for 10,000 again, a variable speed, and you'll notice that it came up to speed as I fed into it and kept a consistent speed. Notice also, though, I've been around the panel once, I'm picking up some marks from this table. This does happen. I will have to do some light sanding, but those marks aren't very deep. I'll be going across it one more time, and then I'll be flipping it over. So give me a minute. We're going to come back after I've got this set for the full depth of cut and make the second pass. This is the second setup, and I've raised the panel raising cutter up, and if you'll follow that panel's edge over, you'll see that it's slightly higher than that surface of the groove, which means when I relieve the back, it will slide into the opening. And that's my measure to be sure my setup is right. Now, how tight should it be? Not so tight you have to wedge it in, because it could break that 1/8 inch piece off the back if it's a real tight wedge. So a little slop is okay. Remember, by the time you add some stain and finish, it's going to fill in that a little bit. All right, now, this piece has been cut twice. We've got the raised area around here, exactly what we want, and I'm about to show you how that's been done. I've taken the guard off of here for purposes of showing you the clarity of it, but also I'm going to take this panel back, I'm going to set it up for the end grain, and I'm going to show you another device that will allow you to make this cut. This device goes on the panel. When I push the panel up against the fence, I push that until the clear plastic part is on the fence, and I tighten it by turning this threaded rod, and if you look at the bottom, you can see that it's clamped on both ends. This edge is parallel to the edge of this. So when I butt this against the fence, my control surface is approximately twice as long as the panel, so the likelihood of me swerving goes down dramatically. Not only that, I've also got a barrier to keep away from the cutter. So what I'm going to do is I'm going to do the 4 edges of this panel to show you that technique, and then we'll take a look at it. This is another way of doing it, and I think seeing more than one way by modeling several methods, you too will be able to do a better job in your shop. Okay, we've got the raised area around the panel. We still haven't got a piece that will fit in here. We're going to have to make a relief cut on the back, and that's going to be the next step. We'll step over the bench and show you a technique there, and then we'll set up a router table to do it as well. So you have 2 ways to do that. So I'll meet you over at the bench here now. I've got a door assembled here, and this is a 3/4 inch panel. This is 5/8, and here's a 3/4 that hasn't been relieved. For this one to be in the same plane as this one so that it sits flat and level across here, the back side has to be relieved. That is, there's got to be a relief cut made on there. One of the easiest methods is to cut a rabbet around that inside edge. Now there are a number of ways of going about rabbeting. You can use a table saw, router table, and so forth. I've chosen a portable router, and I've got a rabbeting bit in here that allows me to make a rabbet of about a ½ inch deep. It's adjustable because I can change bearings on here, but I've got the smallest bearing on right now because I want to remove as much stock as possible so that if this panel were to expand, it wouldn't break the joints in the corners as it expanded. So what I'm going to do now is take one of the 3/4 inch panels that's already been raised on the front side, flip it over, clamp it in here so that I can route the back side away. Now I've set my router, preset it, so that I can make this cut without making any adjustments. I've got a stop over on the router and I'm butted up against that, so I know I'm in the right place after making my test cut. You may have noticed that the ½ inch cutter works much better than a 1/4 inch because I don't get the bumping and jolting. I got just a little bit of tear out in that corner, but otherwise that's fine. Let's prove our arithmetic. Let's check and see how it fits. Oh yes, that's going to be lovely. All I've got to do is put the parts together now. And I'll be satisfied with that. Now, there is another technique we can use. Actually, there's several, but I'm going to show one other technique to you that you can use at the router table. If you have a lot of these to do, it may make it easier. You can see that this panel will slide all the way over. It's designed so that when it is centered, and we'll talk more about that at assembly, it'll be pinned and it won't show either side and allow for expansion and contraction. That's the next step, and we'll show you that at assembly. Now what I want to do is take another one of these 3/4 inch panels and go over to the router table and show you another technique. If you had several panels to raise, this would be probably a more efficient way to do it. So I'll meet you over there. We're about set up. I've got what we call a bowl and tray cutter in here. Cuts a nice round. And here's my test setup. I think you'll agree we've got a nice radius along here. I've done 2 edges, and I've got my depth set. So what I'll be able to do now is relieve the back of the raised panel. And it's going to be about an 1/8 inch depth of relief. And that will allow this piece to fit in. So what I'm going to do now is pull this away, put my guard back in place, turn on my dust collector, and make the cuts. Now the true test is how these fit together. That's real nice. I like that. This also suggests one other test that you could use. You can now say to yourself, well, is that the correct cutter height? Let's look. The top of the cutter should be even with the bottom of that groove, and that will put us in the exact plane we need to be in to get the cut. I think you'll agree we've got a really lovely looking relief on here, and that's what I'd like to see on any panels that I did. I think it's better than the square cut, and it's going to be a lot easier to stain and finish. So that's that. We've got a little sanding to do, and then we can talk about assembly. So I'm going to get those sanders out, get my parts ready, and I'll meet you back at the bench ready to assemble. See you then. Well, as you can see, I've been busy here at the bench putting things together. I've got a few dry clamped, a few clamped, and I thought I'd share a few things with you so you better understand what needs to be done. Let's take a look at this door. You can see it's been coped on both sides with an intermediate rail. And as you look at it, I want to draw your attention to one spot, and that is this corner right here. Notice that that hasn't been trimmed yet. This door isn't glued up, and I can take it apart, and really what I need to do is take a utility knife and cut away that flare along that radius line. Once I've trimmed that and cut any other excess material out, I can put it together and I'll get a tighter fit. Now ideally what the door should look like is more like this one. It's mate, and notice how it's all been cleaned up. Nice clean lines there. All the corners look good, and when I tighten up with the clamps on there, this is just a dry fit and I can hold it together like so. So my joinery is really good. I'm really pleased with what I have, and that's part of what's going on. Notice also that I painted the panels. I didn't want to have any shrinkage impacting negatively upon the actual door construction once it's done. Now when I paint the rest of this, there'll be a slight seal there. I'll pin the panels, and I'll show you that in just a minute. But let's set these aside for a minute. I want to talk about a couple others. This one's been glued and clamped, and it's ready to go. The panel still is free in here. You can get just a little movement out of it, and that's fine. I can fidget with that a little bit. I got a little high spot here. This piece must have been twisted, and I'll take a chisel and I'll clean that off later, and I'll show you that. The back side, it's got a nice rabbet around there, and there's room for it to move. That's what we want to be sure of when we put the panel in. So this is trapped, the glue's on. We'll set this aside to cure, and I've got another one ready to go. This panel's ready to go. Like the other one, I've dry clamped it. I've got just a little bit of an error there and a little bit there. I can live with that. I'm not really concerned with it. My panel will move in there, although slightly. So I'm going to loosen the clamps, and I'm going to break the door apart, much like I've got it now. That is, I want this piece here, this piece here, this piece here, set the panel in. And so now I've got it just like I wanted it in the actual assembly. I see just one little spot here. I can shave that off, get the burr off that, take any fuzz off. Okay, all of those look pretty good. I'm ready to go. Now the best way to go about gluing these is to brush the glue on. So I'll squeeze a little glue in the can here. And then I'll brush it on the joint. Now I want to stay away from that mitered area because I don't want it to squeeze out. So I'm going to just work down in here away from that. And it's good to wet the wood. That is, you need to put some on, brush it on, because you have edge grain gluing there as well as end grain. Most of the strength is in your edges, however. Okay, so I've got some on. I'll tip this up and I'll line that up and just set it in there pretty much how it belongs. Now I'll do the same on the other end. And again, lining it up like so. I've got a little squeeze out there. I won't let that trouble me. Now let's drop the panel in. Ah yes, very nice. And sometimes if there's a little warp, you may have to give them a little friendly persuasion. Okay. I'm being careful. I don't want to glue the panel in. That's very important. If you glue the panel in, if it moves in there, it could actually break the glue joints apart. And that's the last thing we want to have happen. So we want to make sure the panel's free to move in there. Now, things are a little out of alignment. I'm not going to let that trouble me. I'll just tap that down so that it's lined up there. Look at the other end. Looks like this could come down just a bit. Then tap it like so. Look it over. It looks pretty good. Put it back in the clamps. And I want the clamps sitting flat. I don't want any twist in them, because if that were to happen, I could actually clamp a warp into the door. So I'm going to just squeeze down on that till I've got it snug. I'll work them back and forth easy. One hand pressure is all you should need. If you need more than that, you probably didn't have a good fit. Well, as you look at these, you can see the fit is real good. There's just a little bit of squeeze out there. I can reinforce these, and I'll show you how they'll be reinforced here in a minute. But for now, let's set this aside. I'm looking it over. I'm pretty happy with what I've got. Let's put this back here out of the way for the glue to cure. Now, here's one where the glue cured yesterday, and we pinned this. That is, on the back side, if you look in the corners, you can see two holes. Those holes were 5/8 inch pins. The pins go through the cope and stick joint to lock them together. It's like a cross dowel in there. Now, what that does is it locks those corners together to keep the door from racking or turning into a parallelogram over time. Remember to keep those low if you're going to put a decorative edge on the door, because otherwise you're going to shape right through those when you go on to another operation. Now, the fronts of the door, as I look at it, I have a little bit of squeeze out, and I don't know if you can see it well here, but right there is a little bit of glue sticking up. And what I'm going to do is just lightly peel that away. I don't like to wipe it. Some people say wipe it with a damp cloth, but I think that smears the glue around. I'll then put my chisel up vertically and tear away just a little bit of that debris. You can hear the scraping of the glue. And it's important you get all this off, because if you don't, when you go to the stain operation, those will appear as little blotches and remind you that you forgot something along the way. Okay, that corner didn't take much work. That one's pretty nice. I could work them all up, and I'll do that later. For the sake of economy of time, that gives you an idea what has to be done. I can feel just a little bit of glue on those, and I'll clean those up. There is one other thing that we have to do. We have to lock the panel in place. Now, the panel is free to move. As you can see it moving in here, and that's as it should be. But we want that panel to be positioned correctly. One of the easiest ways to check that is to look at the mitered corners. I want those lines to go to these corners all the way around, and it may take a little fudging to get those just right. And it may not always be perfect, but it's going to be very close. That looks good. It's off just a little bit on that one and that one. But it goes almost to the corner. That's as good as I can probably get it, so I'm going to be happy with that. Now what I'm going to do is grasp those so it doesn't move, flip the door over, and on the approximate center line, I'm going to take the same pinner that I pinned that with and drive one pin both places. That will lock the panel in place so it won't move now. Now, the beauty of that is it will expand and contract, but only off the center line. And what that allows to happen is the panel floats in here and doesn't cause any of the joinery in the door to be torn apart. Well, that's what it takes to set a door up. There's a little cleanup to be done on this yet, and I'll get to that in a minute, and we'll take it to the next step. There's one other thing that comes up as an issue, and I wanted to spend a minute or two on that. That is, sometimes we make a nice door like this that has a wood panel in it, yet right above it, such as in a hutch or a bookcase, we want glass doors. After we've spent quite a bit of money on these cutters, we say to ourselves, how are we going to make a glass door? Well, I haven't pinned this. I would pin this after the fact. But what I can do now is I can route the back side, and then I can make a molding for that. So what I want to do first is route the back side of this, and I'll just take a clamp, set it up, move the glue, or otherwise it'll be full of dust. What I've done is I've cut down through here. I'm going to have to go a little bit deeper, or I could leave that as a shoulder. There's 1/8 of an inch there, and that would accommodate my glass. If I were to square this corner out, I could now use some molding to hold the door in. Well, interestingly enough, if we were to take a piece that had been coped, and I would probably cope both sides, if I were to rip that little piece of molding off, guess what that might do for us? Exactly. We could then miter that and use that to hold the panel in place. So now, as you look at the door from both sides, you'd have the same profile. You wouldn't quite have the shoulder because this is 1/4 inch, and there's about a 1/2 inch here. There'd be just a light shoulder. A very small one, but that would allow us to hold that glass in and compensate for the possibility of any glass breakage. When you make a door that has glass in it, the first consideration is the fact that the glass will probably be broken. So keep that in mind. This is a way of allowing your set to do both. On shapers, most times the cutters have a special extra cutter which allows you to make glass or wood door frames. But with the router-based sets, that's not the case, and that's one way of extending the usability of the machine and getting the most out of it. After I had this completely routed, squared out, and the moldings in, I would still pin that, so I would reinforce those joints because the weight of the glass would be heavy and would cause some possible racking or turning of this into a parallelogram. So keep that in mind, a little technique that allows you to go a little further with this. Well, that pretty much covers all of the techniques except one. Let's treat that edge. Sometimes we want to put a thumb edge on, and a bit like this would allow us to do exactly that. Something like this should be used only in a router table, and it's a way of actually putting a decorative grip around the edge. And I thought I'd share that with you. So I'm going to take this over to my router table and set it up now so that we'll be ready to put that molding on. I'll meet you there in just a second. This little edge that's been cut on here makes a dandy finger or thumb pull, and that's its exact intention. It gives us a nice decorative line on the front to add detail to the door, but it also allows us to eliminate hardware and leave a nice plain front that we can pull aside. Now, this cut was made with the piece inverted like so. Before we made the cut, though, we actually added a few things. First, I had to put a spacer on here that was higher than the bit. Then I could put my barrier in position. This barrier then is going to help prevent contact with the cutter, and as big as that cutter is, that's a very good idea. Once I had that positioned, I had to consider that the good face was down. Now, if this panel had stood proud or stuck out, this would be a difficult cut to make. But since it's level, it was an easy cut. All I did was put it down like so and feed it through in this fashion. I did all 4 edges. It was that simple. We've sure covered a lot of territory in the last 90 minutes, and I know that you're not going to master this with one viewing. I would urge you to watch the videotape 2 or 3 more times. Look for all of the safe setups. Ask yourself, how can I do it safer? Try to model the behaviors that make this the safest way you know how. Always think ahead for that. As you've done this woodworking, you know that the best way to be a better woodworker is to learn new techniques and to do more woodworking. Remember, if you want to be a better woodworker, you have to do more woodworking. I also want to point out that there are many videos in my series now. Many things that you could learn from. And thanks for watching the tape. I hope it was worth your time. It's good to have a storage place for those expensive bits when they're not in use. In fact, that's kind of why we made up that nice base and the router table. If you've been admiring these during the course of the video, we'd like to tell you about a set of plans that are available for these. Many of my friends and students like this as well. They asked about the plans, and so we developed a set that are available now. There are 5 pages of prints here and a lot of options that you can use no matter what type of router table you'd like to make up. And there's plenty of opportunities to try your router skills in making this up.